So Rust was born in many ways to solve these issues in C and C++, issues that these languages actually still face today, even though they are, of course, used with some of the biggest programs in the world. Modern C++ has made many improvements over the years in terms of memory safety emphasis, but to be fair, there are still many errors which persist. For example, the use after free errors. So that happens when a program continues to use a pointer after it's been freed, and you get that calling the Lambda function after freeing its reference captured objects. And so there are still many issues that persist, of course. Another differentiating example, the borrow checker, which we're going to dive into detail in the course later on, but just to give you a taste, the borrow check is Rust's secret sauce, meaning that it's tasked with enforcing a number of properties. The borrow checker is basically a part of Rust's compiler that ensures that references are always valid. So it checks to see that there's no ambiguity in the code that would point to an invalid reference in memory. That means that you can't move the same value twice while it's being borrowed. And it's done by essentially initializing all the variables before they are used. If this is a bit confusing right now, we will dive into this later on. So don't worry if you're a little confused. Just take note of the value.